So in this unit, we'll look at how truth tables are related to the standard sum of product or standard product of sums. So the first thing is, if you want to relate a truth table to the standard sum of product. Okay, so in this case, the standard sum of product shown x, function x, written in standard sum of product, has the following truth table. Now, if you want to relate standard sum of products with the truth table, there are two simple rules. The first thing is you consider ones. So each product is represented by a 1, and a 0 represents a complement on the variables. Each product is represented by a 1, and a 0 is a complement in terms of the variables. So now, since we have 3 products here, product 1, product 2, product 3, from that we can tell that our truth table will have 3 ones. 3 ones. So now each one will represent each product. So the first one is, in this case, we have A bar, B bar, C. So this will correspond to a 1, but we know that a complement is a 0, which means the input 0, 0, 1 will be represented, will give us an output of 1. So this comes there. The second product is A, B bar, C bar. This means because a complement is a 0, we have a 0, 0, and a 1 here. So 1, 1, 0 will correspond to a 1. That's that one. And finally, we have ABC, and this ABC, ABC is one of our products, which means 1, 1, 1 will be represented by a 1. So that's simply how you do it, from a standard sum of product to a truth table. So now let's say we are given this truth table. We are supposed to write x in standard sum of products. The first thing we note is that we have 2 ones, which means immediately we know that x is going to be some product plus another product. That's what we know. And the first product will be represented by that. The second product will be represented by that one. Now the first one that we have is 1, 0. So the A is 1, the B is 0. It becomes complement. The second one is the A is 1, 1. The A is 1, and the B is 1. Therefore, our expression, by simply looking at the truth table, we can tell that in standard sum of products, this particular truth table represents this function. Right? So that is the answer. Now, on the other side, when you want to move from the standard product of sum to the truth table, or vice versa, what you do in this case, you do the opposite. You consider the zeros. So each sum is a 0, 0, 0, 0, which means by simply looking at the expression, we can tell that the truth table will have 1, 2, 3, 4, 5 zeros. It will have 5 zeros. And each product will be equivalent to its own 0. And the way it works is the opposite way. The way it works is the opposite way. What does that mean? It means the complement this time around is represented by 1. So let's take, for example, this one. This sum, 1A plus B complement plus C. So this means that this will be represented by, remember, a complement is a 1. This is going to be a 1. This one is going to be a 0. This one is going to be a 0. It means that 0, 1, 0 will correspond to the output of a 0. So 0, 1, 0 will correspond to the output of the 0. Take another one, for example. Let's take this one. A bar plus B plus C. Now what this means is we have, remember, the complement is 1, 1, 0, 1. So 1, 0, 1 will be equivalent to a 0, which is that, and so on and so forth, right? So looking at this example here, so let's say the same truth table, now we want to write it in a standard product of sums. It means therefore we have an expression x, because we have two zeros, we know that we're going to have the first sum times the second sum. So the first sum times the second sum. And in this case, a 0 is a complement, which means the first one, we have 0, 0. So 0, 0, this is the score. The inputs are 0 and 0. And because of that, a complement, a complement is a 1 in that case. A complement, it's high. So which means here, this 0 will be represented by A, not A bar. This 0 will also be represented by B. And in this case, we have 0, 1. And then here it means we would have A plus B bar. So the complement becomes a 1. Complement is a 1. So that is that. And therefore, it means then we can get the solution. And so this is simply how you can then represent from a standard product of sum to a truth table and back, and from a standard product of sum to a truth table and back. So far we have covered Boolean variables, complements, literals, operations, and expressions. We have covered the applications of Boolean laws, rules, and De Morgan's theorem. We have analyzed logic circuits as Boolean expressions, and we have applied the Boolean rules, laws, and the theorem in simplifying a circuit. We have shown what sum of products are, standard sum of products are, standard product of sums are, and how you can convert from standards to the non-standard forms. And we have related the Boolean expressions to the truth table. That being said, then go on to study in the prescribed book sections 4-1 to sections 4-7 as part of your revisions, and consider questions in the tutorials as well.